Question 1. Write down the number 5,689, correct to the nearest 1,000. Well, let's write the number down. Here we have the units, and then here we have the tens, because this means 80, 8 tens. Then we have the hundreds. This number here means 600, and so this would be the thousands. And so, well, this would be 5,000. But it wants it to the nearest 5,000. So, you look at the number, and it's 5,689. So, what do you think it's closer to, 5,000 or 6,000? Well, the answer would be 6,000. And there's a nice way of doing this. Say, for example, you had the answer, or the question rather, 5,620, and you wanted that to the nearest 100. Well, you look at the hundreds column, and then you'd look at this next number here. And if it was a 0, a 1, a 2, a 3, or a 4, then it would have no effect on this number here. So the answer to the nearest 100 in that case would be 5,600. But if this number here was a 5, a 6, a 7, an 8, or a 9, then it would move this number here up 1, and then you'd get the answer 5,700. So can you see now that if I look at this number here, I'll change the colour so you can see it clearly. This number here, well, it's in this category, isn't it? So it's going to have an upward effect on this number here, and that's why I wrote the answer 6,000. It's the same for decimal places as well. If you had the number 5.689 and you wanted that to one decimal place, for example, you would look at this number here. It would again fall into this category here, and it would have an upward effect on this number. So you'd make the answer 5.7 to one decimal place. So a simple question, but there's quite a lot behind it. And as a foundation student, you really need to practice your place value, which is what this topic is, and use these keys here to help you, okay? Question 2. Work out 30 plus 12, all divided by 5 plus 3. Now, this is quite an important question here, because you have a fraction. Now, when you have the division sign, these two dots here represent numbers. And in this case, to look at this fraction here in a simplified form, you will look at the numerator first, i.e. the top part, and you would just add 30 and 12 together. So our next step would be 42, and then you look at the denominator and you have 5 add 3, which is 8. Now, as this is a calculator exam, some people would try and do this all in one go on their calculator, and some common mistakes are that people will type in 30 plus 12 and then do divide 5 plus 3. So how would that look on the calculator if you were to do that? Well, it would look like this: 30 plus 12 divided by 5 plus 3. Now, calculators and computers are trained to work in certain ways, and they basically follow this rule here. You may have heard of BIDMAS, It's nothing complicated. It just means you have brackets to look at first, indices, which are like powers, division and multiplication, and then addition and subtraction. Now, in this case, you have some division to do first. And this is what the calculator would do. It would do 12 divided by 5 first, then you'd be left with some addition of the 30 and some addition of the number 3. And I'm afraid that wouldn't be the right answer. We know if we follow the rules here that 42 divided by 8 would be the answer. And if you like the idea of cancelling down and not just using the calculator straight away, 42/8 is the same as 21 over 4. And you can probably do 4s into 21, because 4s into 20 is 5, and then you've got the 1 left over, which must be divided by 4, and 1/4, or 1 divided by 4, is 0.25. So the answer that you should have is 5.25. But be careful, because if you did it the wrong way, you'd have 30 plus 3 is 33, plus 12/5. And if you want to put that into your calculator, you're going to get 2.4, which would give an answer of 35.4, which would not be correct. There is one way round it, however. If you were to put a bracket here, and a bracket here, and then a bracket here, and a bracket here, you'd then be okay. Because if I choose another colour here, and show you where those brackets would be, they would be here, and here, there, and there. If you type that in, bracket 30 plus 12, bracket divided by bracket 5 plus 3, close bracket, you would then get the same answer, 5.25. So just be careful. If you're not used to doing these, do it in the way I said first, the top part, then the bottom part, and then you can do the division at the very end. Okay? Question 3. Work out the reciprocal of 0.125. Now let's have a look at this keyword here, reciprocal. If you want to find the reciprocal of a number, let's just use a fraction here, say 3/4. Then the reciprocal of 3/4 is 4/3. And if you wanted to find the reciprocal of 4/3, that would be 3/4. So what do you think the reciprocal of 8/5 would be? Well, yeah, it would be 5/8. What in effect you're doing to a fraction or a number is inverting it, or simply you're turning it upside down. So you could say, for this question here, we're starting with 0.125, and you could say the reciprocal of 0.125 is 1 over 0.125. Now, as a foundation student, you may find this quite complicated, but if you look at it this way, and you're not really supposed to write numbers in this way, like a mixed fraction, but if you looked at it as 0.125 whole ones, i.e. 0.125 whole ones, then what you're in effect doing here, to get from here to here, you're just switching the top to the bottom and the bottom to the top, so to speak. So you're just inverting the fraction. But most people who would do this on a calculator exam would have a scientific calculator, which would straight away maybe give you the answer. Because if you were to type in 0.125, some people would know what the reciprocal button would be. Now, do you know what that button is? Well, on some calculators, and I'll just use mine here now so I can be sure it's the same type, you type in the number 0.125 and then you press the button that looks like this. And what happens on the calculator is you get 0.125 and a little box appears here. Now some people know what number to put in there, but some people don't. Now to find the reciprocal is quite complicated, but if you want to say square a number, you do it to the power 2. if you want to keep it the same, you do it to the power 1. If you want to make the answer 1, you have to make it to the power 0. And I can explain this in another question at some point. And there's plenty of questions where I have explained these powers. But if you do 3 to the power minus 1, that is actually the same as 1/3. So if in this little box you typed in -1, that would be the same as finding the reciprocal. So if you type in your calculator 5 and then this button and then -1, that's the same as doing 5 to the power minus 1, which is the reciprocal of 5, which is 1/5. If you tried one of these earlier ones here and you did 3/4 to the power minus 1, and be very careful, you'd have to do open bracket 3 divided by 4 to the power, that little box would come up and you just put in -1 in the box and the answer would come out as 4/3. So that's one way of doing it, and if you did 0.125 to the power minus 1, you would get the answer of 8. But there is another way of looking at it. If you're good at your decimals and you understand that 0.125 is 1/8, and sometimes you're lucky enough to have a calculator where if you put this in and pressed A and S, it would give you 1/8 as its fraction equivalent. Then you can use your common sense and say, okay, I've got the reciprocal of 1/8 to find, and then you can just say, well, it's 8/1, which is the same as writing 8. So a 1-mark question, but there's a great deal of maths behind this type of question, and you really have to understand these key words. Look them up on Google, ask a friend or your teacher, and get to know these words really well, because they're not going to go away, and they're going to be on the exam papers that you're going to do when you do your one for real. Question 4. Here is a list of numbers 1, 2, 5, 6 and 12. And firstly, from the list, you have to write down a multiple of 4. Well, that's nothing more than the 4 times table. That's what the multiple means. So there we go, there's the 4 times table, and what can we see from there? Well, we can see that 12 appears in that list. So 12 will be a multiple of 4. If you want a multiple of 7, for example, that would just be the 7 times table, and so on. So that's the key word multiple. A prime number. Well, a misconception about prime numbers is that 1 is a prime number. I'm afraid it isn't. There's only one even prime number, and that is the number 2. The next number that is prime after that is 3, 5, 7. Now, say for example you thought 9 was the next one. It isn't. The next one after that is 11. But why isn't 9 prime, and why are the others in that list prime? Well, 9 can be written as 9 times 1 or 3 times 3. So it has more factors than itself and 1. It has 3 as a factor. If you look at the number 7, however, the only way you can do that as a product or a multiplication sum is 1 times 7 or 7 times 1. You can't do it any other way using whole numbers. So what's the next number that you think is prime? Well, it's not 12, because that's a multiple of 2, i.e., if you wanted to write the number 12, yes, you could write it as 1 times 12 or 12 times 1, but you could also write it as 2 times 6 or even 3 times 4. So the factors of 12 are not just itself and 1. So the next number that's prime would be 13, and so on. So think of that keyword rather, prime, and then let's look at the numbers. So 1, I'm afraid, is not a prime number. 2 is, and you could have written 5 also. But you only have to write one of those. Question 5. There are 1.5 litres of water in a bottle. There are 250 millilitres of water in another bottle. Work out the total amount of water in the two bottles. Well, not an easy question, so let's have a look, let's break it down. So we have the first bottle and the second bottle. In the first one it says there's 1.5 litres, and in the other one it says 250 millilitres. So I think we need to know something about the word millilitres. Milli comes from 1,000th, that's what it means. If you had a centilitre, well, think of the word cent, that's 1/100th. So a millilitre is 1,000th of a litre. So we can actually convert this one here. Now, a calculator won't help you here necessarily, but if you know that 1 litre would be 1,000 of these little millilitres, and you know that 2 litres then would be 2,000 millilitres, I hope you're okay with 1.5 litres is halfway between them, which would be 1,500 millilitres. So the way in which your calculator could help is you could do 1.5 multiplied by 1,000, and that would convert it to mils or millilitres. So it now becomes quite an easy job because you've done this in millilitres, this one's already in millilitres, and I'm sure that you can add these together and get the answer of 1,750 millilitres. For some of you, you've probably got the idea that if you want to go from millilitres to litres, instead of timesing by 1,000, you would divide by 1,000, and you could write the answer 1.75 litres. Either of these would be absolutely fine. Question 6. Here is a trapezium, and it says this diagram is accurately drawn. You have to measure the length of the line PQ. Well, this will be difficult to show on my computer, so I've given you the answers here, and I'm going to assume that you know how to place your ruler here at 0 and then measure in centimetres to get the answer of 8 centimetres. Now I've put plus or minus 2 millimetres here because in the exam it says that you've got plus or minus 2 millimetres accuracy. So let's have a little look at that, what that means. So 8 centimetres is 80 millimetres, and it's saying you could have an answer as high as 82 millimetres or 8.2 centimetres, or as low as, and you can take the 2 mil off this and have 78 millimetres or 7.8 centimetres. So it's saying any answer between these two would be good enough. And then for the angle, again, I'm assuming that you can use a protractor. If you can't, then there are plenty of videos on YouTube explaining how to use a protractor, so please look at those. And then for this angle here, you're allowed to have 35 degrees plus or minus a tolerance, that's the way of calling it, a tolerance of 2 degrees, so as high as 37 and as low as 33. Do keep in mind though one thing that some teachers don't tell the students, and that is sometimes teachers photocopy a paper, and when it's photocopied sometimes it's scaled up or down a little bit, so when you come to measure something which is accurately drawn, you may not get the answer that the mark scheme wants. It's only when the exam company sends you out the proper papers, which they have printed themselves, that you would actually get these exact answers. So be careful, if your teacher's photocopied this, you may not quite get the same answer in the mark scheme, but it won't be much different. So that's question 6. Question 7. To solve this equation, First of all, let's simplify the left-hand side. And we'd have f plus 2 more f's plus 1 more would be 4f equals 20. Now 4f is the same as 4 times f, and so if you just read the equation to yourself, 4 times something is 20, you'd probably be able to work out that that something was 5. But the way of doing it would be to do the inverse operation of multiplication to both sides of the equation, because it is a balance. We have a left-hand side and a right-hand side, and this sign says that the left and the right-hand sides are the same. So if we divide both sides by 4, then we have f equals 20 divided by 4, which gives you 5. Now let's look at this second equation, this second balance. We have 18 minus m equals 6. Now some of you may see that 18 minus 12 equals 6, and if you wrote that down as workings, that should be fine, and you could write the answer 12. But if you start with the question and try and do the same thing to both sides to get the value of m, let's see if this works. Could I add the same thing to both sides? Well, yes. So if I added m to both sides, I would then have 18 equals m plus 6. And the reason for that is, if I started with negative something and I added exactly the same amount, these would cancel out. It's like having, say, negative 2 and 2 would be 0, and I wouldn't write 0 here. Now looking at what I've written here, you can probably see that 12 plus 6 is still 18, so 12 is still fine. But what I've done is I've tried to do the same thing to both sides to get the answer. So what about now if I took away 6 from both sides? Well, I'd be left with 18 take away 6, which is 12. The plus 6 and the minus 6, when added together, would cancel to give 0, and I'd just have m left on the right hand side. So what I'd have is 12 equals m, which is the same as m equals 12. You could have done this in a different way. You could have taken 18 from both sides, and you would have been left with minus m, or negative m, is 6 take away 18, which is negative 12, and then say to yourself, negative something is negative 12. Well, the only way that could balance is if m was equal to 12. There are other ways of doing these, but for this question for now, I'll just leave it there and we can move on to part C. It says simplify d squared times d cubed. Well, d squared is d times itself, and d cubed is d multiplied by itself 3 times. D cubed does not mean 3 times d, because 3 times d is the same as d plus itself 3 times. So be very careful. D cubed means d multiplied by d multiplied by d again. So how many times have we multiplied d by itself? That's called the power of d, and in this case I hope you can appreciate that the power this time is 5. It will be d to the power of 5. Question 8. Jane writes down the following: 3.4 multiplied by 5.3, and she says the answer is 180.2. It says, without doing the exact calculation, explain why Jane's answer cannot be correct. Well, let's just have a quick look at what we have here. I think a nice way of answering this question is saying something like using estimation, and we could say that's roughly 3 times 5. We would expect something around 15. So using estimation, we would expect 15 to be the answer to 3.4 times 5.3. So using estimation, we would expect 15 to be what I would say the approximate answer. The approximate answer to 3.4 times 5.3. Jane has 180 roughly, which is over 10 times too much. Another way of writing this is you can say using estimation, the answer should be in the tens. However, Jane's answer is in the hundreds. That would be okay because the examiner would know you're talking about something called place value. So we would expect it to be roughly 3 times 5, which is 15, which has units and tens, 1, 10 and 5 units. But Jane's answer of 180.2, well, it has a little bit of a decimal going on here, a tenth. That's neither here nor there. But it has no units, but it has 8 tens and even 100. So that's going to be far too much. And I don't think as a foundation student you would use the word the magnitude is wrong, but if you have heard of this word magnitude, the magnitude is like the size of a number. So if you expect the answer to be 15, the magnitude is in the tens. But when Jane wrote an answer of 180, the magnitude was in the hundreds, so the magnitude didn't match. So there's plenty of ways of answering this question, but try and have a good idea of what magnitude means and how you can use estimation to help you here. And another important thing that I'm noticing in these new exams is there's a lot of words and you've really got to be really good at writing your explanations. So try and use some, for example, and I'll use another colour, try and use some workings to support your English, okay? Because if your writing lets you down a little bit, at least your maths here, in terms of your number and what you write in terms of number, will support your answers. So try and get them both working together, and that will give you, most of the time, 4 marks. Question 9. The two numbers A and B are shown on a scale. It says the difference between A and B is 48, and it wants you to work out the value of A and the value of B. So the key thing here, the key word for me here is difference. So how different are they? Well, how many gaps are there here? 1, 2, 3, 4, 5, 6 gaps. Now this is a calculator paper, so if you took the difference between them, which is 48, that difference between them here, that large chunk that I've just drawn in, is worth 48, and it's split up into 6 equal pieces. So if you use your calculator, or if you know 48 divided by 6 is 8, then that's really good. So this would mean that if this is 0, which is given, this would be 8, this would be 16, this would be 24, and B would be 32. and then if we start going back from 0, this would be negative 8, and this here would be negative 16. So try and use the key words to help you work out what to do in the question, and then it should be, much easier for you. Question 10. Complete this table of values. Well, you've got to interpret this table first. It's saying that the value here for n is 12. That's what this column stands for. So it says the value of n is this column, and the first number in the column is 12. And we have to work out what this column is standing for, and that is 3 lots of n plus 2. So it's really trying to test whether you understand what the expression 3n plus 2 actually means. And you should be okay with 3n meaning 3 times n, and then add 2. But we know that n in the first case is 12. So we've got 3 times 12 plus 2. Now, if you remember BIDMAS, where you have brackets, indices or powers, division and multiplication, and addition and subtraction, well, we have some multiplication to do here first. So we've got 3 times 12, and you can use your calculator if you need to, that's 36, and then add 2 gives us 38. So the value of 3n plus 2 when n is 12 is 38. Now it's telling us that 3n plus 2 is worth 47, so let's write that mathematically. And we have to work and find out what n is. So it's almost like having an equation here if you want to do it mathematically. You could guess and you could work with some numbers. So 12 would give 38, 13 would be 3 times 13, which is 39, add 2, which would be 41, and you could keep doing trial and improvement in your head or writing down some notes here. So for example 13, you could have said, well, 13 times 3 plus 2, that would give 41. Maybe you'd want to try 14 and so on. But if we look at 3n plus 2 is 47, we can treat it like an equation, and we can take 2 from both sides to begin with, and that would leave us with 3 lots of n is 45. And 3 lots of n means 3 times n is 45. And you can either use your calculator to help you here, because if you want to know what n is, you can divide both sides by 3, because this was timesing and we had to do the inverse operation to both sides to get n on its own, and we end up with the answer n is 45 divided by 3, which is, on your calculator if you wanted to use it, 15. But don't forget, if you had have said 3 lots of 15 plus 2 as workings, which gave you 45 plus 2, i.e. 47 as an answer, then your workings would have supported what you'd written here, and that would have been fine also. Question 11. It says the same number is missing from each box. Find the missing number. Well, with a calculator, a lot of people would have used trial and improvement, and that is fine. And you would have stumbled across 7 times 7 times 7 is 343, and you'd get the answer. But what does that actually mean? If you take the number 343, it means you have to do something to it to get an answer of 7. Well, here's an idea. If you had a box times another box and the answer was 16, you would probably know that the answer was 4. And you may understand that to get the answer 4, you can do the square root of 16 to give you 4. Or alternatively, 16 to the power a half equals 4. Now when you write to the power of a half, that's the same as square root. So if you wrote in your calculator 25 to the power, and you just put in a bracket here, 1 divided by 2, so 25 to the power, a half, you would get the answer 5. 100 to the power, a half, that would be 10. It's the square root. Now in this particular question you had three things multiplied by each other. They were the same thing to give 343. Well, if you think of this example as being the square root, think of a square with the same length. You're timesing the length to get the area. In this situation, think of something where you multiply three things together, and that would be a cube. So if you do length times the width times the height, you end up with a cube. So what we could have done in our calculator is do the cube root, which is 343 to the power 1/3. But just be very careful when you put this into your calculator. Just type in 343 to the power, however you do that. Bracket is really important, 1 divided by 3. You must have the brackets here. So let's have a look at part B now. Well, here we have 4 to the power of 4. So that's 4 times something, the same number, times something else, times something else. Now, the question at the beginning could have been 4 boxes in a row. And that means you just have to put 4 in here. And you can use your calculator. You're going to get 4 times 4 is 16, times 4 is 64, times 4 is 256. And you can just type in 4 to the power of 4 in your calculator and you'd get exactly the same answer. Question 12. Here are two numbers, 29 and 37. Nadia says both of these numbers can be written as the sum of two square numbers. Well, let's write down the square numbers. We have 1 times 1, that's 1, 2 by 2, that's 4, 3 times 3, 9, 4 times 4, 16, 5 times 5, 25, and 6 times 6, 36, and of course this list carries on. But can we make, as Nadia says, can we make these numbers, both of them, the sum of two square numbers? Well, if we add 25 and 4 together, we will get 29. So yes, 29 can be the sum, add, of two square numbers, 25 and 4. What about 37? Have a look at the list. Can you make 37 by adding two of those numbers from the list? Well, you can. You can do 1 and 36. So 1 and 36 makes 37. Again, that's a sum of two square numbers. So yes, Nadia is correct. And we've shown our workings very clearly as well. So just say yes, Nadia is correct. Question 13. Here are the first three terms of a sequence, 32, 26 and 20. So if we write these down, you should be able to notice that they go down by 6 each time. It's probably easier to see that with these two. And then just verify it with these two, and yes, it's the same. So it's a linear sequence, so that means it's going down by, or up or down by the same thing straight away when you compare the numbers. So it's safe to say that the next one will be 6 down from 20, and so on. So we'd have 8 for the next one, down by 6 again, that gives 2. And if you go down by 6 again, well, be careful, if you're on 2 and you go down by 6, then you've gone 1, 2, 3, 4, 5, 6. You're -4. So that's the first term in the sequence, that's less than 0. And then you'd have to go down by -6 again. So back by 6 again would be even further back, which would be -10. Question 14. Here is a triangle ABC. A to B to C. It says mark with the letter Y the angle CBA. Well, C to B to A makes this angle. So there would be Y. It then says here is a cuboid. Some of the vertices, now if you don't know what vertices are, then this is going to be difficult. I.e. if you were in an exam and you didn't know what vertices meant, then you'd be finding this hard to answer. So this keyword is very important. The word vertex, which is the singular, and vertices is the plural. So vertex is the singular and vertices is the plural, means corners. Okay? So it says some of the vertices are labelled shade in the face CDEG. Well, these are the vertices here. They've been labelled. And it says some of them, i.e. this one's missed out. And you've got a shade in CDEG. Well, CDEG would be this face here. Okay? And I'll just shade that in there. And that would be the answer. Then it says, how many edges has a cuboid? Well, here's a cuboid shown here, so this one will do. And we'll just say, right, 1, 2, 3, 4. Then we'll have 5, 6, 7, 8. And then lastly, I'll do another colour here. We'll have 9, 10, 11, 12. So it's 12 edges. Question 15. It says there are 5 grams of fibre in every 100 grams of bread. And it says a loaf of bread has a weight of 400 grams. So if the bread weighs 400 grams, that's 4 lots of 100 grams. And we know in each 100 grams there are 5 grams of fibre because it tells us this. So there'll be 4 lots of these 5 grams here, which is 20 grams of fibre in a loaf. And I'll just put fibre there so you can see what I'm doing. Now it says that there are 10 slices of bread in a loaf. And each slice of bread has the same weight. So if we know there are 20 grams of fibre in a whole loaf and there are 10 slices, then if we divide the 20 grams by 10, that will tell us how much is in each slice, and that would be 2 grams of fibre per slice. Okay, so that wasn't too bad. Question 16. It says, give an example to show that when a piece is cut off a rectangle, the perimeter of the new shape is less than the perimeter of the rectangle. Well, I think some people find these quite tricky. So let's try and replicate the rectangle. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And then 3 up here. And then we can complete that one. So I'm going to try cutting off this much. Now, what has that done to the perimeter? Well, if we count round here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the perimeter is 16 to begin with, but what is it now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Still 16, you see. so we haven't actually made the perimeter any different. So we definitely know that this will be the answer to part B then, because we've already worked out that if we do this, the perimeter is the same. So there's the answer for part B, which is handy. So we have to go back and think about this one now. So let's go again. So we've got our original, like so. And we've got to take something off for the perimeter to be less. Well, I'm going to be a bit more drastic this time, and I'm going to cut across here. So we know that we had a perimeter of 16 to start with. What will this one give? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So if we cut this bit off here, that would give us a perimeter of 14, which is less. We've done one which is the same. Now we want one that is greater than the perimeter of the rectangle. So we'll start off with the original, like so. And we've got to cut something off. Well, let's have a go at something like so. Let's have a look. Let's see what that one does. So what I'm doing is I'm trying to make the edges a little bit more jagged, and because the edges are where the perimeter is, I'm trying to produce a little bit more perimeter if I can. So let's count round now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I've actually managed to increase it quite a bit more. So why don't you have a go at that? Perhaps you can try and increase it more than what I have already, and I think I know a few ways that you can do that. Okay, let's move on to another question. Question 17. It says ABC is an isosceles triangle. So we'll just label A, B and C here for now, and we'll put these dashes on the lengths to represent that they are the same length. It says when angle A is 70, so we'll put that in here. There are 3 possible sizes of angle for B. Now we've got to work out what they are. So I've labelled in this diagram A is 70. You know angles in a triangle add up to 180, so these two must be the same because base angles of an isosceles triangle are equal, so they would have to be 55 each. So one possibility for B is 55 degrees. Now let's draw the triangle again, and this time we'll put A here, doesn't matter where we put B and C. Isosceles, and it says A is 70, so I'll just get the same colour as before. A is 70. So that means this one would be 70 because the base angles are the same. 70 and 70 makes 140, leaving 40 for angle B. And then there's one other possibility as well. So we'll have A here, and we'll just switch B and C. So if A is 70 again, then B has to be 70, and we're not bothered about C. We know it's 40 anyway, but we're all finding facts about angle B, and there's the 3 angles that B could possibly be. Part B. It says when angle A is 120 degrees, there is only one possible size of angle B. Well, let's have a look. So we'll draw an isosceles triangle, but this time we need the top angle, so that's good enough. So we'll mark these. Now that's acute, so that's not going to be more than 120, and neither can that be. But this one, if we force this one to be 120 degrees, okay, you know, in reality it would probably look more like this, But if we say that's 120 degrees and we put that as A, then it says there is only one possible size of angle B. Well, that's true, because if you have one obtuse angle in a triangle, the others have to be acute. Because if you take a situation, for example, where you've got a right-angled isosceles triangle and A was 90, these would be 45 at most. So we've got A as 120, which leaves 60 for the base angles. So wherever we put B, left-hand side or right-hand side, then they're going to be worth 30 degrees each. And we'd say 30 degrees, and our explanation is because once an obtuse angle is taken, the other two have to be acute and therefore the base angles. So that's the explanation. So let's move on to the next question. Question 18. In a breakfast cereal, it says 40% is fruit and therefore the rest is oats, it says, and that would mean 60% would be oats. Now, if we had 40 parts per 100 to 60 parts per 100, then if you want to write this strictly as a fraction, you could say 40 100ths to 60 100ths. So I'll write that up here. Now that's fruit to oats. Now I could times both sides by 100 and I'd get 40 to 60 because the hundreds on the denominator would disappear. I could then divide both sides by 10 and that would give me 4 to 6, and then I could halve and get 2 to 3, then I could halve again and get 1 to 3 over 2. Now with a calculator, what you could have done is you could have gone 40 to 60 straight away, and you could have done that here, by the way. So you could have done 40 to 60 here as well. I just showed how to make a percentage work. So 40 to 60, and then to do it really quick, you could have divided both sides here by 40 on your calculator. You know that would have been 1, and then whatever your calculator says for 60 over 40, and I bet 9 times out of 10 your calculator would say 3 over 2 or 1.5. So you can say 1 to 3 over 2 or 1 to 1.5 because that's the form that it wanted. I think that's called a unitary ratio, where one of them is 1. Now it says a different breakfast cereal is made using only fruit and bran, and it says the ratio of the weight of fruit to the weight of bran is 1 to 3. So here's the fruit and here is the bran, and it says what fraction of the weight of this cereal is bran. So the nice thing about ratio is it tells you how many parts are involved. So we've got 1 part and 3 more parts, so there's 4 parts, and for every 4 parts fruit gets 1, bran gets 3. Okay, and they're equally distributed. So if you want to work out what fraction of the whole weight of this cereal is bran, well, you just look at how many parts bran has out of the total number of parts. So the answer is quite simple, it's just 3/4. Question 19. Well, this is all about buying boxes of chocolates and trying to buy as many boxes as possible, given that you get 3 for the price of 2. And Ali has £50. Now I find these questions very, very difficult myself, so you have to bear with me here. Now, if you get 3 for the price of 2, I think we should really work out what the price of 2 actually is going to be. So you've got a calculator, don't forget, but I'll just use this. So I'll have 13 here. So £7.38 for 2. Now that would mean that if we use £7.38 up, that would give us 3, don't forget, because we get 3 for the price of 2. So we want to see roughly how many £7.38 we can squeeze out of a £50 note. Now, I know if I had £7.38 and I times it by 7, that would be close. So you can use your calculator here, and because 7 sevens are 49, that would be really close, wouldn't it? So if we just work that out, £7.38 times 7, that would be £51.66. So he wouldn't be able to do 7 of those. So what we could do is, we could say £7.38 times 6. So let's go with that. And that would be £44.28. Now, when I say 7.38 times 6, that means 6 lots of £7.38, which means I'm getting 6 lots of 3 boxes. Because don't forget, for every £7.38, we managed to get 3 boxes. So we know we can get 6 here times 3 is 18 boxes, and that's £44.28 spent. Now, unfortunately, he can't buy 3 for the price of 2, because if you spent another £7.38, we already know we'd be over. We'd be at £51.66. So if we do 50 minus £44.28, and again you can use your calculator, I won't. That's £5.72. Now what he'd have to do now is he'd have to buy 1 box without the deal, okay? So he'd have to buy another box, that is £3.69, so that would leave £2.03 left over, and that would give him 1 more box, so he'd be able to buy 19 boxes of chocolates altogether, and he'd have £2.03 left over, which wouldn't be enough to get another box of chocolate. Question 20. Well, this is all about Venn diagrams, and I haven't done those since I was at school. They've never been on the syllabus since I've been a teacher until now. So let's have a look if I can remember how to do these. So I know with a Venn diagram, you start with a rectangle. And you want to have a look at how many different types of set you have. When I say a set, I mean I'm looking for an A and I'm looking for a B. Now it says here that A is multiples of 2, and it also says something quite important here, that there's something called a universal set. It's this symbol here, which is quite a strange symbol. But that's the universal set, and it tells you that this Venn diagram must contain 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now as there are 2 sets within it, A and B, we'll draw these as circles. Now normally you don't have 2 circles like this. What you would normally have is 2 circles like this. And there's a reason for that, because if we look closely here, we can see it says A and then this symbol B. Now that symbol here means intersect, so it means where A and B overlap. So if I label this one as A and this one as B, it could be the other way round, it doesn't matter. We know that they intersect, i.e. they overlap where the numbers 2 and 6 appear. So we can put 2 and 6 in there. So that's that done. We also know that A must contain multiples of 2, i.e. all the numbers in the 2 times table. So it already has 2, but we need to put 4 in here as well. It has 6 then, because don't forget if we look at A and we draw the circle, it goes around 2 and the 6 as well. So that's 2, 4, 6, and then there's another multiple of 2, 8, and then one more, that's 10. Now, A and then this symbol here, B. Now this is easier to remember, this symbol. I remember it at school as U for union. And if you have a union, it has its members, and it's what A and B have in common together. Okay, so if you include all of A and all of B together, then that's A union B. And A union B has the numbers 1, 2, 3, 4, 6, 8, 9 and 10. So we already have 2 and 6 here. We have 4, 8 and 10. And we've got to have 1, 3 and 9 included somewhere. Can't be an A because A only has multiples of 2. Therefore, the 1, the 3 and the 9 have to be in B. So what does that leave us? Well, if we look at all these numbers here, and I'm going to do these one at a time, and I'm going to put circles around them. So I'm going to do a different colour. So 1 is accounted for. 2, 3 is, so is 4. Now, we don't see 5, but this symbol told us that it had to be within that rectangle somewhere, so we can just put 5 in here somewhere. Doesn't matter where it is, as long as it's not inside A or B. So that's 5 done. 6, that's sorted. 7, well, I can't see a 7 either, so we can put 7 in there somewhere. And then I can see 8, and I can see 9 and 10. So that's the Venn diagram complete. Now, I think there's one little thing that I have to do for the Venn diagram, and I'm not quite sure of this, and I'm sure someone will tell me. And that is, I think I have to put the symbol outside here. Anyway, so that's that question done, so we can move on. Question 21. There's a scatter graph or a scatter diagram, and it shows the information about 10 students. It says for each student it shows the number of hours spent revising and the mark the student achieved in a Spanish test. So we can see the hours along the x-axis and the mark gained on the y-axis. It says one of the points here is an outlier, and all that means is that one of the bits of data seems to be out of kilter or slight difference to the others. Okay, it seems to stand out like a sore thumb, and you can see that it's this one here. So we can write down the coordinates as 4 along, 10 up. So we can write it as 4, 10. That's easy enough. Now let's have a look at the next part of the question. It says, for all the other points, draw the line of best fit and describe the correlation. So our line of best fit, and I'm not brilliant at doing these on this, but we'll have a look, have a go. So we'll get our line here, and we'll put it through the crosses so we have an equal number on either side and get it roughly correct. So that one there's a bit of a problem, so I'll just move it slightly this way. Okay, so that's my effort. Of course they give you a tolerance here, you haven't got to get it exactly correct, but as long as you've got it roughly correct, that's fine. And then, so I've done the line of best fit, and I'm going to describe the correlation now, or the correlation between the hours spent revising and the mark. And it seems to say here that the more hours spent revising, the higher the mark gained. So we could say a strong positive correlation. If the crosses aren't as gathered around the line as they are here, you don't have to use the word strong. You could just say positive correlation, or just write a sentence in English saying the more hours spent revising, the higher the mark for the Spanish test. Okay, but positive correlation is much quicker. It says here now, a different student revised for 9 hours. Estimate the mark this student got. Now, a lot of students sometimes don't put the line of best fit on because it doesn't always ask you to put it on, you see. It might just go straight to this part of the question here. And some people forget to do this, and that's why they're using their eye too much and they're not using a line of best fit to help them. So we go to 9 here. This is where you should use a ruler, but I'm not. So I go from 9 here, go to my line, and then read along really carefully, but you'd use a ruler, okay? And look at the scale, so 62, 64, 66, 68, 70, so I'd say around 63. So the estimate of the mark would be around 63 marks. It says the Spanish test was marked out of 100, and Lucia says, I can see from the graph that had I revised for 18 hours, and then it cuts off, let's have a look, I would have got full marks. Right, let's have a look. So we can get this back in order here. Let's have a look if I can do that. It's going to be quite difficult, so let's have a look. I'll do this way. Okay, so she said if I had revised for 18 hours, I'd have got full marks. Now, is that true? Well, she may be misled here because she might be thinking, yeah, if I've got 18, I'm off the scale. However, you could say different arguments, and I'm trying to think of the most efficient argument you could put forward, and I would say this, and that is full marks are hard to get no matter how much revision is done. Ability counts. So what I'm saying is, if you had a maths test, say a higher paper or even a foundation one, everyone has their own natural ability at a subject, and doing revision will improve your performance, that is sure, but it can't guarantee you full marks, okay? And I think sitting here, we all know that's true. So revise, yeah, that's brilliant, but it does not mean that if you spend 1,000 hours revising a maths paper or a Spanish paper that you're going to get full marks. We all know that to be true. So that's what I would write for that comment there. Question 22. The length L centimetres of a line is measured as 13 centimetres. Correct the nearest centimetre. Complete the following statement to show the range of possible values of L. Well, we'll come to that in a bit. So if we look at the measurement of 13, then it's given to the nearest unit. So if we take a unit and we split it in half, we'll get 0.5 either way. Now, I'll show you the relevance of this in a minute. So when we're coming to look at numbers and how they round, say we had a measurement of 13.2. Well, to the nearest whole number, that would be given as 13. If we had 13.4 and we wanted that to the nearest unit, again, that would be 13. So what we're trying to do is, we're trying to push this number as high as it can possibly be to be rounded to 13, and to have it as low as it could possibly be to be rounded to 13. So for example, if we had 12.8 and we wanted that to the nearest unit, i.e. to the nearest centimetre, we would say 13. So how low can this number go here before it's not rounded to 13 again? Well, if we chose 12.4 and I said to you, is 12.4 closer to 12 or 13, you would say 12. But if I said 12.5, then when you've used rounding before in decimal places and such, you've always been taught that if the numbers are 5, a 6, a 7, 8 or a 9, then it rounds the next number up. So the lowest it can be is 12.5, and that would round to 13 to the nearest centimetre. So how high could 13 be? Well, 13.4 would round to 13, and 13.5 would really round to 14, wouldn't it? Because remember, 12.5, that rounded to 13. So this is where we come back to this. So let's write this out clearly. Now, if we start reading from here left to right, L has to be less than, well, anything less than 13.5. Even if we had something like 13.49973 to the nearest unit, that would still round down to 13, because this number here is a 4, a 3, a 2, a 1 or a 0, which has no effect on the number before it. So that's why this is a less than sign, okay? Because if it was equal to 13.5, i.e. I did this, then it would round up to the next one, 14, and would not be allowed. So let's have a look at the next part. When you're reading inequalities, they're quite difficult. But what we're trying to say is, when we've got an inequality, we've got a left-hand number and a right-hand number. And that's kind of like the range of possibilities that you can have. So we've done this one here, so we know that L has to be less than 13.5, but it has to be also greater than or equal to, well, what number do you think? What did we discuss here? Well, we come to the conclusion that it could be as low as 12.5. So if we put 12.5 in here, then if we read from left to right this inequality, we have 12.5 is less than or equal to L. Now if 12.5 is less than or equal to L, that means L would be greater than or equal to it. So think again, does this make sense? If 12.5 is less than or equal to L, that means L must be greater than or equal to it. So if you're not quite sure on that, ask your teacher, and I'm sure they'll explain this part to you. It's quite difficult, especially on a foundation paper, I have to say, but that would be the answer here. And you may have seen this when you've come across class intervals before, where you've got a measurement and it can be between some certain values. So the measurement could be this one, but it can't quite be this one, hence the different signs here, less than or equal to and just less than. Question 23. The line L is drawn on the grid below. You have to find an equation for the straight line and give your answer in the form y equals mx plus c. Well, when you've got y equals mx plus c, you have this is the gradient, which tells you how steep the line is, and this number is where it cuts the y-axis. So this number here is the steepness, otherwise known as the gradient, and this number here is known as the y-intercept. And don't be worried about the word intercept, it just means cut, so it's where it cuts the y-axis. So we can see here it cuts at 1 plus 1. So we know the answer is going to be y equals some gradient with x plus 1. So all we have to do now is see just how steep the line is. And the nice thing about straight lines is they're very predictable. They never change, they're always the same. So this one is going uphill, so we definitely know one thing, and that is the number here is going to be positive. Okay, it's not going to be a negative number. So let's start from somewhere. Let's say here, and let's go along 1. So if I go along 1 on the x, then how far do I have to go up to get back to the line again? Well, I have to go 1, 2 units. So that means for every one I go along, and I can do this again, look, go along 1, up 2, along 1, up 2. In fact, if I go back 1, it's down 2, back 1, down 2. So there's a really nice rule there. And if you can ever find how much you have to go up or down, if you go along the x-axis, i.e. increase, then you've found the gradient. So here's the key. If you can go along 1, the amount you go up by is the gradient. So the gradient here is 2. So the line is y equals 2x plus 1. In fact, this number is also very useful because if you went along, say, 2, this is the multiplication factor that you'd have to go up by. So if you went along 2, you should be going up 4, twice as much. So 1, 2, 3, 4, and so on. Okay, so that's a little insight into how to find the intercept and gradient if the line is given for you. Question 24. It says Jenny works in a shop that sells belts. The table shows information about the waist sizes of 50 customers who bought belts. And this is from the shop in May. So it says calculate an estimate for the mean waist size. So what we generally do in this situation is we know how many of each size was actually purchased. It tells us that here. And it classifies the waist size for each belt being small, between 28 and 32, not 28 but can be 32, medium, can't be 32 but anything more than that right up to and including 36, large 36 to 40 but not 36, and so on. So you've got no overlaps because if your belt size was 32, you'd definitely know you'd be in here. And if it was 32.1, then you'd definitely be in this class interval. So if we know that 24 small belts were bought, then what size of waist do we go for? Do we go for 28, 32, or something else? Well, the idea around this when we're estimating is to use the term central tendency. Now, I wouldn't worry too much. It basically means you always go with the centre number here, the central one. Okay? So what would be the middle number here? Well, the nice way of doing it is, and you can use your calculator here, if you add the two extremes up, 28 and 32, you get 60, and then you can halve it, find the average or the mean, and you would get 30. So when I said average there, I'm talking about the mean. So we can say that an estimate would be that 24 people had a waist size or needed a belt for a waist size of 30. So we're not guessing saying, oh well, it could have been 2 at 28.7, 5 at 31.6. We're just saying we're going to go with our best option, which is on average things tend towards the centre, and we're going to say 24 of them were 30. Likewise, we're going to say that 12 of them were halfway between the 32 and the 36. So if we do 32 and 36 and add that up, we get 68, and half of that is 34. So we're going to have 12 lots of 34. Then we're going to say that 8 of them were, well, not 36.5, not 37.2, we're going with the middle value again. And the nice thing about this, these end bits go up in 4s, so the middle bits will go up in 4s. They have to go up in proportion. So if you don't believe me, you can do 36 and 40 and halve it. So we should get 38. And then lastly, 6 of the belts, and we can say the size was halfway here. And you can probably see halfway between 40 and 44. It's quite easy to see, and that's 42. So once we've done all those multiplications, all that means is all of the belt sizes added together. 24 of these, 12 of these, 8 of these, and 6 of these. Now, normally for the mean, what we do is we divide by the total number of belts bought, and that tells us clearly here that that's 50. A common error, believe it or not, is that some people just say 1, 2, 3, 4 numbers and they divide by 4, but that's not what you do. So let's use the calculator here and see what that's going to be. So I'm going to do the top row first. I'm not going to do it all in one go. 24 times 30 plus 12 times 34 plus 8 times 38 plus 6 times 42, and that gives me 1,684. Divide that by 50 and I get 33.68, and it's measured in, I don't know what the measurement is, oh yes I do, inches. Okay. Now as these were given to the nearest whole number, I'm not quite sure what I would say actually. I think I'll give it to 1 decimal place, although you probably should give it to the nearest inch, but I'll say 33.7 and I'll write down that 1 dp. At least I've given all the information anyway, so I should be able to get all of the marks based on that. Now, a very, very difficult thing to understand here, so let's read it slowly. This is what makes, I think, a lot of the foundation papers really difficult in my opinion. So, you know, I do feel for some of the students here. It says, belts are made in sizes small, medium, large, extra large. Okay, that's shown there in the table above. And Jenny needs to order more belts in June. And it says the modal size, now don't forget modal means the most popular. Okay, the modal size of belts sold is small. Okay, so we know that the small belts sell more than any other, and you can see that from the table as well. It says Jenny is going to order 3/4 of the belts in size small. So she's going to place an order and 3/4 of them, in her opinion, are going to be small. The manager then says to her, you should not order so many. Who is correct, Jenny or the manager? Well, if you think about it, there was 24 small belts sold out of the 50. Now that's roughly half. Okay, so roughly half of the belts sold were small. And Jenny is intending to make a purchase and have 3/4 of them being small. But if you think about it, if only a half of them were selling as small, that's still quite a good majority, but you wouldn't want to necessarily get 3/4 of your stock as small, would you? Okay, so in that respect, I would say I would think the manager is correct, because it doesn't warrant spending all that money and having 3/4 of your stock being small when only half of them, compared to all the other sizes, sell. And I've just finished the explanation off here. Manager is correct, does not match with the half actually sold. Question 25. The diagram shows part of a wall in the shape of a trapezium. Karen is going to cover this part of the wall with tiles. Each rectangular tile is 15 by 7.5. Tiles are sold in packs, and there are 9 tiles in each pack. So Karen divides the area of the wall, so we'll do that first. We'll find the area of the wall. Now, if we want to find the area of a trapezium, it's quite nice. We don't have to bother about this triangle at the end here. We can just say that if we did 0.8 times 2.7, and you can do that on your calculator, that would be too much of an area. Okay? But if we did 0.8 times the shorter side, we would not have enough. So if we do the average of these, i.e. add up the one that's too much, the one that's not enough, divide by 2, that will be the area of a trapezium, and that always works. So if you aren't sure about how to find the area of a trapezium, then if you look at the numbers we have here, 0.8 is called the perpendicular height, the one at right angles, okay, and that's the distance between the pair of parallel lines. So if we look at this, we can bring out 0.8 over 2 as a factor, and then we just have longer length plus shorter length. And the formula of area of a trapezium is something like h over 2a plus b. So here we can see the height. A is one of the sides that is parallel and B is the other one. So all that aside, we find the area of the trapezium first, and on a calculator then we can do that. And the answer I get for that is, and this is in metre squares, don't forget, because we've got metres by metres, so I get 1.8 metre squares. Now again, that's quite difficult to convert, so let's have a look. We've got 1.8 lots of 1 metre squared. Now a metre is 100 centimetres by 100 centimetres, so 100 by 100 is the same as 1.8 times 1 times a metre square is 100 centimetres by 100 centimetres. So on your calculator, if you just multiply 1.8 by 1 by 100 by 100, we can do that now. You don't have to do any guessing, just put the numbers in. 1.8 times 1 times 100 times 100, and we get 18,000 centimetre squares. That's the total area of the wall. Now, using her method, she divided that, so Karen divides the area of the wall by the area of a tile now. So the area of a tile, well, it says here, so that's the area of wall. Area of tile is, it says 15 centimetres by 7.5 centimetres. So we can put that in our calculator and we will get centimetres by centimetres, which is centimetre squares. So we'll have 15 times 7.5, and that is 112.5 centimetre squares. So what Karen does is she takes the area of the wall, and that's in centimetre squares, divides by the area of a tile, which is in centimetre squares, divides them out, and you put 18,000 divided by 112.5, we get 160 tiles. So using Karen's method, if she needs 160 tiles and there's 9 tiles in a pack, then if you do, we'll do that here, if you do 160 divided by 9 on your calculator, you get 17.7 recurring packs. Well, it would make common sense that she would have to purchase to the nearest pack 18 packs with her method to get this job done. So we've used Karen's method to work out an estimate for the number of packs of tiles she needs to buy. There it is. Now we're going to have to look at part B of the question. Now again, this last part, let's read this carefully. Karen is advised to buy 10% more tiles. Well, that means that if she had 160 tiles to begin with, don't forget, down here, and she was asked to buy 10% more, well, you should know that 10% of 160 is 16 more tiles. Now, if she's bought 16 more tiles, then surely if there's 9 tiles in a pack, she'll have to buy 2 more packs. And she assumes she will need to buy 10% more packs of tiles. But she, by her estimate, purchased 18 packs, and 10% of 18, so 10% of 18 packs is 1.8 packs. So Karen's assumption is not correct, because if 1.8 packs is 10% more, because don't forget 18 was her estimate, 2 more packs would have to have been bought, and that is more than 10%. So 10% is only 1.8 packs, but she actually had to buy 2 more packs, didn't she? So her assumption is not correct. I think this question is probably the hardest one on the paper because there's so many words and so many things to do. I think these are, in my opinion, harder than some of the higher questions. So I do feel for the students here. If this question wasn't necessarily on the higher, and I think you find on average there are less questions with so many words on the higher paper the higher up you get. You've really got to have your wits about you to do these questions well. So hopefully that was explained reasonably well for you, but I'm sure you've got other ways of doing it yourself. Question 26. Factorize x squared plus 3x minus 4. Well, when we've got a quadratic and we're asked to factorise it, generally means we're wanting 2 brackets here. So we're wanting a situation where we've got 2 brackets multiplied by each other. Now, a good way of working this out is just to do a grid, a multiplication grid, and try x here and x here for starters, because you know that x multiplied by x is going to be x squared, and we definitely wanted that. Now we have to choose some other values. Now the way that we do this is, the way I do this anyway, is I just look at the number 4 and I can split it into its factors. So I could have 4 with 1 perhaps, we can give that a try. And let's see what x times 4 is. Well, that's 4x. And then we have 1 times x, which is just x. And then we have 1 multiplied by 4, which is 4. Now, we know then that it can't be plus 1 and plus 4 because we have a plus 4 here, but we need to have a negative 4. So one of these would have to be negative. So can you see which one would give the answer? Well, if we made this one negative, then we'd have here negative 1 times x would give negative x, and then negative 1 times positive 4 would make this one a negative 4, and that's what we want here. And then we've got 4x and minus x, which gives us the 3x. So x plus 4 times x minus 1 does the trick, and that's the same. You could have written x minus 1 multiplied by x plus 4 is exactly the same. Now, if you didn't think it was going to be 4 and you thought it might be 2 and 2, well, you could have tried that, and you can skip forward if you don't want to see this. So you could have tried 2 and 2. You know that one would have to be plus and one would have to be minus because we needed this negative here. But then if you tried this, then I'm afraid you'd have x squared minus 4, which is most of what you want, but these would cancel to 0 and would not give you the 3x that you needed here. Question 27. Here are the equations of 4 straight lines. Line A is y equals 2x plus 4, line B 2y is x plus 4, and so on. And we've got to see that 2 of these lines are parallel, and we have to write down which 2 are parallel. So if we look at A, we have y equals 2x plus 4. And if we compare that to the straight line formula y equals mx plus c, where m is the gradient and c is the intercept, then all we need to do is get all of these lines into this form, and then we can compare the values of m, i.e. the gradient. So for this one, the gradient is 2. For line B, we have 2y equals x plus 4, which would mean y would be x divided by 2 plus 4 over 2. Now 4 over 2, that's just the intercept, we don't have to worry about that. But y equals x over 2 means the same as y equals a half x plus 2. So the gradient for this one is just 1/2. So they're not the same so far. So line C, well, we've got to do a bit of work on this one. We get 2x plus 2y equals 4, which is the same as 2y equals minus 2x plus 4, which is the same as y equals minus 2 over 2x plus 4 over 2. Notice I'm not cancelling here just yet. I'm not bothered about the intercept, I just want to look at the gradient, and we have minus 2 over 2, which is the same as negative 1. And then finally D, we have 2x minus y equals 4, which is the same as minus 2x plus y is negative 4. That's the same as timesing everything by negative 1. Then I can add 2x to both sides and I'll have y equals 2x minus 4. And here we can see the gradient is 2. So the gradient was 2 in line A, and the gradient was 2 in line D. Now, I made an assumption that you know that if the gradients are the same, then they are parallel to each other. Now, this fact separates them from being the same line because the fact being that the intercept here is at negative 4, so if I had the y-axis and the x-axis here, this one cuts at negative 4 and this one cuts at positive 4. So although they have the same gradient, i.e. go along 1, up 2 and so on, they are indeed parallel, they're not the same line. So that's that question done. Question 28, a very difficult question. Very difficult. The densities of two different liquids, A and B, are in the ratio 19 to 22. So let's get that down first. So the density of A to the density of B is in the ratio of 19 to 22. It says the mass of 1 centimetre cube of volume of liquid B is 1.1 grams. So if you understand that density is how much mass you can cram into a certain volume, then you'll know density is mass per volume. Okay, so we'll use that formula. So the density of B is the mass of B over the volume of B, and it tells us that the mass of 1 centimetre cube, i.e. the volume, so we can say that's 1 centimetre cube, and the liquid B, the mass is 1.1 grams. So it's 1.1 grams for every or per 1 centimetre cube. So the density of liquid B is 1.1 grams per 1 centimetre cube. So as you can probably tell, this is quite a difficult question for me to explain. So if we do that on the calculator, not that you need to do 1.1 divided by 1, you're going to get 1.1 grams per centimetre cube. Okay, so there's the density of B. Now let's get back to this ratio. Let's make this a unitary ratio by dividing both sides by 22. So we get what 1 for the density of B would be 19/22 as much for the density of A. So can we use that to help us? Well, yes we can, because the density of A will be then 19/22 of the density of B, which is 1.1 grams per centimetre cubes. And I'm definitely going to do that on my calculator because I'm not going to take any risks. 19 divided by 22 times 1.1, and I get 0.95 grams per centimetre cubes. So that's the density of A. Now let's have a look at a little side issue here, which is liquid C, which is made. Now, liquid C is comprised of a volume of, and I've done that, V of C, volume of C, and it says here 20 centimetre cubes. Now, we know that the mass of this liquid C is made up from 5 centimetre cubes of liquid A and 15 centimetre cubes of liquid B. So we know the relative densities for B and A now. So we know for each 1 centimetre cube we're going to have 1.1 grams per centimetre cube for liquid B and only 0.95 grams per centimetre cube from liquid A. So I can say that the mass of liquid C will be made up of 15 lots of the 1.1 grams, because it says it here, 15 centimetre cubes worth, plus 5 centimetre cubes worth of the other liquid A. So I'll do that on my calculator. So that's 15 times 1.1 plus 5 times 0.95, and that gives me the mass of liquid C of 21.25 grams. So we're home and dry now, because we can now say that the density of liquid C is the total mass of it, which is 21.25 grams, over the volume, which, don't forget, it told us 20 centimetre cubes, and that gives us, I'll check on my calculator, divide by 20, and I get 1.0625 grams per centimetre cubed, or centimetre cubes. So that's probably the second most difficult question I've done for months from these videos. Some of you probably find this really easy and brilliant. I'm glad that you do. It's probably one of my most difficult ones. I would dread doing these in an exam. But that's as best as I can do. If you can do better, please do let me know. Okay, thank you.